Morning everyone and welcome back to Piping Engineers. So guys, I hope you guys are doing well. So in today's video we will be discussing about one of the most commonly used and essential components in piping system, the gate valve. Friends, in this session, I will take you through what is the gate valve, how it works, type of applications, internal parts, and many more important characteristics. So, which you should know as a piping or a maintenance professional. So, guys, for more videos and updates, please like, follow, and subscribe to our channel. We will continuously bring this type of videos which will increase your journey towards learning. So, let's begin our today's video. So in today's first slide, guys, before starting, what is a gate valve? So gate valve, you all would have seen in your day-to-day life. You would all have seen it in the plant. So gate valve is basically an isolation valve. So this means its primary purpose is to either completely allow or completely stop the flow. It doesn't have that principle that you can throttle, means half of the flow can be passed through the gate valve. So guys, what it operates using a flat or a wedge shaped gate. So this is the flat or wedge shaped gate, so that moves up and down to start the flow. So this wedge is connected with this handle. When we rotate this handle, this wedge goes up and down, which starts or stops the flow. So friends, as I already mentioned, unlike control valves or throttling valves, gate valves are not designed to regulate the flow. Make it in your minds, they are not designed to regulate the flow, and this is one of the confusion people generally have. So gate valves are used widely in water supply networks, industrial pipelines, and utilities, where certain sections must be isolated during maintenance, repair works, or service expansions. So in this slide you can see the symbols also. So you can see this is the symbol which you will see commonly in the PNID, and this symbol means that the gate wall is open. So when the symbol is has blanking inside it truly means the gate valve is closed. So I hope this is the basic of the gate valve, and you all would have seen how what is the gate valve and where it is used and what are the purposes for which we use the gate valve. Moving on to the next slide. So moving this is the slide here. So can you throttle a gate valve? So it is very important to note that gate valve should not be used for throttling, as I mentioned in previous slide. So what happens if a gate valve is partially opened, or the fluid becomes turbulent, it can cause vibration, erosion, and cavitation, or over the time it will damage the valve. So what happens when you try to throttle the valve, it damages the seat and gate valve, which leads to your leakage and reduced sealing capacities. So what happens, guys, you would have seen gate valves comes in two main categories, so in which two main stem configurations. So one is rising stem gate valve and the other one is your non-rising stem gate valve. So these two pictures are the one is for rising stem gate valve and another is the non-rising stem gate valve. So what happens, as the name suggests, so the stem is visually moves up. You can see the stem is coming out of the hand wheel when the valve is open, and it moves down when the valve is closed. So rising stem valve is used where the space constraints are not there, while the non-rising stem valve are used where we have the space constraints, especially let's say in pulpits or underground pits where we have gate valves for the underground pipelines. We try to use the non-rising stem valve. So the stem threads, they are outside the flow path, which reduces the corrosion. So this is was one of the important thing, because the wedge is connected directly with the the stem, and the stem is connected with the hand wall also have threads which are located with the stem. So when the hand valve is rotated, the stem rotates in same direction and the stem moves up and down. What happens in non-rising stem gate valve? In this type, as I already told you, the stem does not expand upward. The stem threads are inside the valve and they are exposed to a flow medium. So the design is suitable, as I told you, where there is space is limited, but is also more prone to corrosion due to contact with the fluid. So the stem goes directly in contact with the fluid. So that's why whenever there can be problems of cavitation or erosion when longly exposed to water surfaces. I hope you would have seen understood the difference between the rising stem and non-rising stem. and where they are used and where they are not used. So guys, this all is a theory which I have typically mentioned for you guys, which you can read through through the video after pausing it. Moving on to the next slide. So characteristics of gate wall, a very important slide. So here are some key characteristics of the gate wall. Although in background we have this image where different parts of gate wall were shown. So the characteristics of gate walls as, so gate wall as uses a solid wedge shaped gate to stop the flow. So this is the basic design characteristics of a gate wall. So when compared to a ball wall of same size and same rating, gate wall always have a large body height because of vertical movement of the gate. You would have seen in ball wall there is no vertical movement, there is a horizontal movement, and in gate wall there is a vertical movement. So these are multi-turn valves, meaning hand valve must be rotated multiple times and to fully open or close. You would have seen this. So these are not quick action valve, guys, unlike quarter ton ball valves. So again, you have to rotate a lot of times, a lot number of times the hand wheel, then the valve will completely get open or completely get closed. While in a quarter ton ball valve, it is very fast opening and fast closing. So although gate valves are generally more cost effective than ball valves, they are more prone to corrosion and internal wear over long term use. You would have seen in cases where gate valves handle goes out of service, and even sometimes the stem loses the wedge, the gate valve, the wedge and stem connection loses, and wedge is even seen sometimes fixed in the, like it loses the connection, so it doesn't moves up and down. So the stem which connects to the hand wheel to the gate is one of the most vulnerable component, which I told you. Understanding these features help you to do the right selection of the gate walls, right selection of the walls, I will say, because there are many constraints while we do the engineering. Application constraints are there, space constraints are there, and maintenance considerations are there. I hope the basic characteristics of gate walls you would have understood. We will bring a series where we will explain each wall one after the other in our next videos. Moving on to the next slide, guys. So here we will be discussing about different parts of the gate wall. So first is body. So body is the, guys, main pressure rating component. It houses the gate, seat, and flow passage. So you would be knowing that walls come in the pressure rating class 150, class 300. Basically, the classes are selected on the pressure temperature rating or the design pressure temperature rating of the system. Next is your bonnet, guys. So the bonnet is mounted on top of the body. It encloses, the and protects the stem. So this is the main bonnet and provides the structural strength. It also forms it also, it is the main component of the gate wall, because it is the part where all the components, all the major components, I will say, the stem is there, and it basically mounts all the height of the body, and it is the pressure containing envelope. Next is your gate or disc. So gate is the, this is the gate here. It is the moving part that blocks or allows the flow. So basically this is the one which will restricts the flow, which will restrict the flow, or which will allow the flow to open. So when the gate is fully lowered, the flow is shut, or when lifted, the flow resumes freely. Next is seats. It's very important thing. One is your gate seat. The, if you remember in last slide, I have mentioned to you guys that if the we use try to use the gate wall for throttling, so these are the seats, guys, which gets destroyed, and due to which the leakage starts coming. So there are two seats, one on each side of the gate. So you can see one here and one here. This ensures proper sealing, as I already mentioned you, because it's a metal to metal contact and seating is required. In metal to metal contact, we cannot provide 100% sealing, so we have to provide EPDM seals. So seats may be integral part with this body and are made as separate rings. Next is stem. So stem is basically the part which moves up and down. The stem connects the hand wheel, the part which we rotates, and gate, and transmits the opening and closing. Depending upon the design, as I mentioned earlier, it can be rising or non-rising. So understanding these components helps in troubleshooting the walls issues and performing maintenance or replacement efficiently. We have tried to explain you guys everything which was important for the gate walls, and I hope this session would help you clarify fundamentals, including how they work, their types, internal components, and applications. So please, if you have any questions, feel free to write in the comment section. For more videos, please like, subscribe to our channel. We will be happy to help if you have any queries. So thank you for watching the video.